Hello, this video will cover the last half of the 2.4, 2.5 module. This is actually from the 2.5 section, inequalities involving quadratic functions. So that's what we're going to do, is we're going to solve these. So let's begin with an example. Solve the inequality x squared plus 5x plus 4 greater than 0 and graph the solution set. So we're going to graph this x squared plus 5x plus 4. We're going to look at the y-intercept, plug 0 in and you get 4. X-intercepts, factoring is probably the most efficient way to do this. X plus 4 times x plus 1. So x is negative 4 and x is negative 1. Now let's locate the vertex. Negative b over 2a, which turns out to be negative 5 halves. And when we put that in, you get negative 9 fourths. So the vertex is negative 5 halves, negative 9 fourths. So let's kind of get a good sketch of this graph and see what it looks like. So if you notice, the negative 5 halves, negative 9 fourths is a point down in the third quadrant. The x-intercepts are negative 4, negative 1, and a y-intercept of 4. So that's the shape of the graph. So where is the x greater than 0? Well, a function is greater than 0 when it's above the axis. And so if you notice, it's above the axis in the red. Notice the open circles, meaning they're not above the axis there. So it's only in the red where the graph is above the axis, and that's where it's greater than 0. So to the left of negative 4 and into the right of negative 1. So negative infinity to negative 4 or negative 1 to infinity, that is where it is greater than 0. The function is greater than 0. And looking at the number line, to the left of negative 4 and to the right of negative 1. Notice there is open parentheses, which means that we don't include those endpoints. So let's look at another example. This one actually has a couple of methods to do it. I'll show you the method I prefer first. It's called we'll call it method 1. X squared is less than or equal to x plus 6. So we do this one the same way I just did the last one. You rearrange the inequality so 0 is on one side. If you remember, the last example had 0 on the right side. So it's very similar. X squared minus x minus 6 is less than or equal to 0. You graph this function. So you find the y-intercept first, and that's negative 6. Put 0 in for the x. X-intercepts, factoring is probably the most efficient way again. So x minus 3, x plus 2. So x equals 3 and x is negative 2. The vertex is negative b over 2a, which turns out to be 1/2. Now we pop that number back into the formula, and we get negative 25 fourths. So the vertex is 1/2 comma negative 25 fourths. So let's look at a rough sketch of this one. So the 1/2 comma negative 25 fourths is that point way down in that first quadrant. The 0, negative 6 is at the y-intercept, and the two x-intercepts are located. Now, same thing as the last problem. When is this one less than or equal to 0? Well, it's less than 0 when it's below the axis. So it's in red. But notice this time the x-intercepts are now solid red. Why is that? Because it says less than or equal to. So this time we're going to include those numbers. So in the red is where it is true. So it's from negative 2 to 3. And again, looking at the number lines graph, negative 2 to 3. So very similar to the previous example. But here's another example, and I'm not a big fan of it. Some people are, because the left side and the right side are easier to graph individually. I'll show you what I mean. So method 2, if f of x equals x squared, that's an easy graph to do, and x plus 6 is an easy graph. So graph each of the, instead of bringing the x plus 6 to the left side, treat them as separate functions and graph them both on the same coordinate plane. So graph x squared and graph of x plus 6, and there it is. Okay, now the question is, when is the f of x, the blue graph, less than or equal to the green graph, g of x? Well, points of intersection, we got to find those first. So we know when it's below it, it's less than, but where is that? So we need to find the points of intersection. And this is the reason I'm not a big fan of this, because you got to find these numbers anyway. So x minus 3, x plus 2. And so 3 and negative 2 are the points of intersection. And they put those points on the coordinate plane. Negative 2, 4, and 3, 9. So again, the question is, when is the function less than or equal to g of x? When it's below it. So they're going to put that in red where that's going to happen at. F of x is going to be less than or equal to g of x when you see the red part. So between negative 2 and 3 is when the graph will be below the green graph. So that is when this is a true statement. So again, negative 2, 3. Same answer as the previous method. So you just got to pick a method that you prefer and you stick with that. And again, there's the number line with those solutions, negative 2 to 3. Okay? Let's look at another example. Solve the inequality negative 2x squared plus 8x minus 9 less than 0 and graph the solution set. So we look at this one. So we're going to graph this. We find the vertex, negative b over 2a again. Plug that 2 in and you get negative 1. So the vertex is 2, negative 1. So the y-intercept, plug 0 in for the x, is 0, negative 9. So let's see what we have on the graph. So 2, negative 1, that upper point, 0, negative 9. And so using symmetry, I'm going to get another point off of this. So by symmetry, 4, negative 9 is also a point, and they plot that for you. And then they go ahead and graph the parabola. Now, if we're looking at the parabola, and you notice, well, why don't you find any x-intercepts? Well, obviously, it doesn't have x-intercepts. So in this case, this graph is going to stay below the axis. So when is this graph going to be below less than 0? Is always. So this function is always less than 0, so the solution set is all real numbers. So what would happen if you switched it around to greater than 0? That means there'd be no solution. But in this case, it's all real numbers because the graph stays, there's no x-intercepts. So if there's no x-intercepts, the graph is going to stay above or below. And so, how do I know there's no x-intercepts? How do you do that? You set the function equal to 0 and you solve it. What do you think is going to happen here? Yep, the discriminant is going to be negative and you're going to have complex zeros like we had before in those previous videos. So this one will not have x-intercepts. So because it stays below the axis, and so in this case it's all real numbers. And here's the number line. Okay? So that completes this video. If you have any questions, as always, you feel free to contact me, and you have a good day.